All right, so hi everyone. Thank you for sticking it out until the last talk. I'm going to be talking to you guys about moving a research community towards reproducible and reusable workflows. The talk went through some growing pains, so I'm now talking about more of the community and process aspect, as well as, of course, the final product and Earth system model evaluation workflow built on Jupyter notebooks. So, for those of you who might not live in the Earth system modeling world, I first will just give a little bit of background on what that looks like. So I'm going to be talking primarily about CSM, which is the Community Earth System Model, which we work on at NCAR, the National Center for Atmospheric Research. The way that CSM works is it consists of a number of coupled components, all of which together represent the Earth system. So there's models for things like the atmosphere, land, rivers, land and sea ice, waves, ocean, etc., as well as biogeochemistry components that are connected to the land and ocean models. And all of these come together to give us a picture of the full climate system and lets us do things like make projections for the future based on different scenarios. So NCAR provides output from CSM as a resource for the community. There are a number of different runs that we provide, all of which model different scenarios based on different things that might happen with carbon emissions, things that people might want to try with geoengineering, and so on. You might have heard of CMIP, the Climate Model Into Comparison Project, which looks at different climate scenario forcings. We also have the CSM Large Ensemble and some runs dedicated to geoengineering. The idea of this is that we provide these to the public so people can use them and analyze them however they want to. However, these model runs produce very large amounts of data to analyze, as you can imagine. The data is on the order of terabytes, and it looks like tens of thousands of netcdf files, along with additional metadata stored in the original run location, which can be pretty difficult to analyze without additional support. We usually need high performance computing for this sort of analysis. At NCAR, we have a supercomputing center in Wyoming that we use for this, but lots of other centers solve this problem in different ways. So I'm talking primarily about model diagnostics. So what are those? Diagnostics analyze and plot model output. So they're basically any sort of code that gives us metrics like monthly climatologies of different variables, things like sea surface temperature, etc., the El Nino Southern Oscillation Index, any number of different things that we might want to look at in order to figure out what the model results are actually telling us about the climate. For example, for development runs, if you're running the model over and over again, trying to tweak different parameters and make sure things look right, you want a good workflow to be able to quickly look at these things and figure out what's going on. Again, this is a sort of general concept, and this sort of code can look like anything from individual Python functions, notebooks, any number of other implementations. And usually people are running them as part of larger workflows where you want to run multiple of these diagnostics at once. For some background on how these have been run in the past, the NCAR community has been migrating from a different language, NCL, which stands for the NCAR command language, to Python in the recent past. So NCL is now being retired, and we're migrating to Python for these analysis functions. And this means that there have been some growing pains, and different groups have solved the problem of migration to Python in different ways. So what comes of this? Right now, everybody in our community is doing diagnostics pretty differently. People have a bunch of different Python functions, bash scripts that wrap them, that create things that you submit to a scheduler. Some people have notebooks that you're copy and pasting paths into. Some of those plots are getting pushed to websites where they exist and people can look at them, but there's not a ton of context. You get the picture. This has kind of been a common theme throughout the different talks today. It's quite messy and difficult for people to reproduce and reuse. So my job has been to try to figure out a workflow that can move our community towards something better and more unified. So what do we want out of this? We want support for both new and legacy diagnostics code. So while in an ideal world, we would have a whole bunch of nice, pretty notebooks with explanatory text, we also have a lot of scripts and functions that we would like to support as well. So we want back compatibility. We also want better shareability for communicating results. So while images of plots are great, it's really nice to have the context that comes with a Jupyter notebook where you can add what you're thinking about what you're seeing or more details about what's being plotted. We want less dependency on data locations. I mentioned hard-coded paths that you might have to copy-paste in between places. This makes it really hard for people to share their code both within the organization and within the broader community. So we want some way to make that a little bit cleaner or abstracted away. We want less dependency on specific computing infrastructure. Currently, a lot of things only run on NCAR's high-performance computing systems, and in the future, we would like for the community to be able to use these tools as well and have it not be dependent on that. And finally, and perhaps most importantly, we want support for both standard and curiosity-driven workflows. That's kind of buzzwordy, so what does that mean? So we want it to be able to do two different things. We want this workflow to be able to both run out of the box just as you get it for iterative refinement, so you can easily get a standard set of diagnostics for a model run. So like I mentioned before, if you're trying to run the model over and over again, tweak little things to see what things look like, we want you to be able to take this workflow, run it right away, and have something nice to look at. However, this standard sort of analysis isn't what everybody wants to do, and we also want to be able to support curiosity-driven analysis, where people can add their own notebooks, calculations, explorations, whatever, to this standard suite of things, make interpretive notes, and share that with other people as well. So we're trying to make a workflow that can do both of these things with ease. So what does the workflow look like? Well, it's called NB-SQUID, so that stands for Notebook-Based Super Customizable Infrastructure for Diagnostics. This is basically just the little infrastructure package that I've been working on to support this workflow for folks at NCAR. So how does it work? It relies primarily on notebooks, as I've sort of been alluding to. Notebooks make it really easy to have explanatory text cells so that it's not just data. And also support curiosity-driven development, so you can try different things and see what you've done in the past. And we also want to support Python scripts, so things are back compatible. One important thing is the notebooks are parametrizable. I'm going to talk more about this later on in the talk, but basically this makes it so you can plug in arguments as if the notebook were a function. So rather than having to go in and manually copy-paste in your paths, what variables you want to look at, what date range you want to look at something over, that happens automatically, and you get a computed notebook at the end of it. Potentially standardizing that API so that you have a lot of different notebooks, all of which take in the same inputs, would be a great future goal. We want the capability to build a Jupyter book for sharing. I'm sure you guys have seen a number of Jupyter books throughout this conference. They're a really great tool to be able to host something online, send somebody a link, and have some nice content that you can share without much extra work, and we want to be able to support that for our use case. We want support for catalogs so that data access is simpler. Catalogs are files that keep information like where the actual paths of all of your different data files live, how they can be aggregated, and so on. That makes it so you're not dealing with hard-coded paths within your diagnostic code itself. And finally, we want multiple options for the computing background for accessibility around NCAR. That's currently a work in progress. I'm going to be notating what's currently a work in progress throughout the presentation, because this is very much an ongoing piece of development. So a conceptual overview of what this looks like. So like I mentioned before, you have a set of parameters. I have some examples of what that could include there, as well as a data catalog that tells you where all of the data that you're working with lives. And this tool parameterizes and executes all those notebooks programmatically. You don't have to look at the notebooks themselves. All of your config stuff gets plugged into them, they get executed, and then you run a command to build a Jupyter book. And I'll go into more detail of how this looks in practice later on, as well as a demo. So this is a brief glimpse at the tool stack that's being used to support all of this. I mention all of these more later on, but I just wanted to give huge thanks to any of the developers and maintainers of these packages. They've been super, super useful for this workflow, and it wouldn't work without them. So yeah, now I'm going to go into a little bit more detail about each of the different functionalities that this workflow supports. So like I briefly mentioned before, catalogs enable easier data access. So in this case, when I say catalogs, I specifically mean intake catalogs, which are specialized for Earth system models through the intake ESM package. That allows us to abstract away the details of the file paths where all of our data lives, and also allows us to aggregate thousands of files into data cubes for easy analysis through tools like Xarray. We use custom tools for building these catalogs, mostly specific to NCAR model output. Parametrizing notebooks makes them reusable and act more like functions or scripts. So notebooks are great for exploratory analysis, documenting things, etc., but not so good for integrating in a reusable workflow. To address that problem, we execute them programmatically and add a cell around the top of the notebook with parameters at runtime. So you have a number of variables that you're sticking in, things that you might imagine like the date range, what variable you're plotting, etc. Those get inserted as the notebook is run by this tool and used later on in cells down below. We also have the functionality to parameterize markdown cells with Jinja. So if you want to, for example, change the title of the whole notebook based on what you're plotting, it's easy to do that. We also have caching functionality. Sort of, it's a work in progress. But basically, when diagnostic elements are run, NBSquid keeps track of the metadata of the run, like all the parameters they were run on, when the catalog it's being run on was last modified, etc. So if the exact same thing is requested, we pull from the cache instead, which saves computation time. And finally, the option to create a Jupyter book. This NBSquid includes a wrapper to build computer notebooks into a custom Jupyter book, which is a collection of HTML files that can be shared with other people just as the HTML or published online. It's a quick, organized way to share diagnostics results, so you include all of the cells, how things were made, etc., rather than just the images of plots hosted on a website that has been used in the past. And having this available online could also improve documentation availability for those simulations hosted as community resources that I talked about before. So diving more into what the code looks like, everything that is in charge of what's happening in running a diagnostic collection lives in a single YAML file. That contains information like what data catalog it's being run on, the path to where all the notebooks you want to run live, global and notebook specific parameters, and any config that you might need for the Jupyter book. You first run the command nbsquid run on that YAML file, which does the whole parametrizing and executing process. That gets you a set of executed notebooks, and if you then want to turn that into a Jupyter book, also using the Jupyter book config that was in the original file, you run nbsquid build, and you get a Jupyter book out of that, which then you can put wherever you want. So in general, this is infrastructure that enables a flexible system. The idea is that we are going to provide collections of standard diagnostic notebooks along with config files to run those different sets out of the box. So if you say run the ocean model and want to do diagnostics on that, you download the notebooks, download the config file, and you can run that just like that. However, if you want to customize it, you can also take that file and adding your own notebooks in the library or remove some of the ones being run if you don't need those, etc., and run something however you want. So infrastructure exists to enable all of these features that I've talked about, but you're not limited by that. If you have any notebook that you want to run, you can have it get parameterized with whatever parameters you want and run it. So it's super flexible. All right, so super quick demo on what this looks like. My computer was struggling a bit with the display earlier, but oh boy, okay. Let me get that reset real quick. Our Jupyter hub has been a little bit flaky lately, so I think it crashed while I was giving the talk. All right. hopefully that runs successfully. We'll see. Yeah, so while I'm waiting for that, I will quickly scroll through a couple examples of what some of these inputs might look like. So the config.yaml file that I'm running this on, this has a ton of comments, but it's mostly comments, has paths to where I'm pulling data from, where the notebooks live, what environment I'm running things in, and the parameters that I'm sticking into each notebook, as well as some Jupyter book stuff. The notebooks that I'm parametrizing, this is just a pretty bare bones example, but I have this little landing page here, which you'll see what that looks like once it actually gets run, and a number of diagnostic plots that are being calculated by this notebook. And again, these haven't been parameterized yet. They're currently getting run. So I will give that a second. It takes a minute or two because there's a number of calculations that have to happen. But in the meantime, if anybody has a quick middle of the talk question or anything, I'd be happy to take that. Yeah, Max.
So does this require building the catalogs ahead of time, or is it?
Yes.
Do you have the option to build the catalog as a part of one of these steps?
Yeah, so that's kind of an open question. We've strongly considered building in on-the-fly catalog creation so that you just need to point it to where your files are. The catalog gets created as a part of the process, and then it runs from there. But currently, that's not built in. Currently, you build it separately with other tools that other folks at NCAR are developing, and then stick it in here. And yeah, ideally, the catalog is being maintained external to this as well. So if data moves, then that moves in the catalog. That's sort of a important consideration. Yeah. Oh yeah. Hello. Do you have a question? Yes.
Just a comment that I've been doing something similar for a report, but not for reproducibility. Well, not for other people to use, really. Just me writing a report for work, and using similar workflow, kind of. And so I'm feel validated by doing a similar thing, and I've been really pleased with it too.
Yeah, it's a really hard problem to solve. There's just a lot of moving parts. All right, so this finished running. So what I did was I ran those notebooks that I showed you guys before and then built them into a Jupyter book. So I'm going to show what that Jupyter book looks like now. All right. I don't know what the best way to make this nice and visible is. So yeah, currently I just have these HTML files showing up in my Jupyter Hub session, but if you put them somewhere else, you could just host them in your browser. So you can see that in that landing notebook that I showed before, just as a sort of very small example, it didn't have that cell in it before, and now it does, and that markdown cell got parameterized as well. And for an example of some plots that got created with data that I passed in through the parameters, we have a number of plots that are just comparing a couple of model output variables to observations. I'm scrolling through that kind of quickly because what's actually in there isn't the main point of the presentation, but we got plots. So yeah. All right, and so final thing is current work and open questions. So what I've been working on is the challenge of migrating the existing diagnostics that we already have. So the current workflow for diagnostics, specifically for the ocean model that we're working on, because I'm in the oceanography section, is pretty complicated. There's a number of diagnostic functions that live in one package. That's a bunch of Python scripts that get configured by a YAML file, submitted by a bash script to a scheduler. Those create output files that get displayed through another set of notebooks. Basically, it's complicated. What I've been working on is converting that process to a set of compatible notebooks that works with this workflow, so the people that I work with can use that and have a better workflow for their model work. This is just for the ocean component of CSM. Other model components use pretty different diagnostics infrastructure, but we hope that by creating this workflow, it'll be flexible enough to get adopted more broadly across NCAR. I've also been working on a number of infrastructure changes in the development. One of the bigger ones has been migrating the back end of how notebooks get run from just Papermill to Plumer, which is a workflow orchestration engine. I've been using their API for that. That's going to enable executing diagnostics in parallel. So if you have multiple notebooks that don't depend on each other, you can run them at the same time. Running non-notebook diagnostics, like just Python files rather than notebooks. And also managing the dependency graph. So if you have multiple stages of notebooks where you have data files getting passed around, or one of them is actually creating the data and another one is being used for visualizing it, it manages that. So if anybody in the audience has tried to solve some of these problems or worked with Plumer before in particular, I would love to talk about that. On that note, I've also been thinking about different orchestration or workflow engines that exist. There's a lot of them, and how they could be useful for this sort of work as well. I've also been working on enabling compatibility with a non-NCAR computing environment for things like setting up Dask clusters. That's a work in progress, but it's definitely on the table. So, yeah. I guess I have a little bit of time left over at the end, but I just wanted to stress the point that I'm super open to ideas and collaborations. If anybody has looked at workflows or solved problems like this before, I would love to chat and share experiences. I have links to where the main code for this lives, a couple of usage examples, and my contact information. So yeah, I can take questions.
All right, any questions in the room?
Looks like fun.
Do you have any virtual ones? Yeah.
Can you just talk a little bit about what specific problems you've had with your workflow engines?
With what? Sorry. Oh, with workflow engines?
Workflow engines that you're trying to evaluate, new ones, and
Yeah, so in the past, this was just using Papermill. If that's something that you've worked with before, that's enabling the steps of parametrizing, so adding that cell at the top and executing notebooks programmatically. So you don't have to go in and execute cell by cell, it just runs the whole thing. I think that Plumer is probably the best one for adding the additional functionality that I'm thinking about, like running notebooks in parallel and all of that other stuff, because it's sort of an existing tool that does some of this like data pipelining work with notebooks integrated in it, but it doesn't have all of the things that we want, like that specific compatibility with catalogs, exactly what we want out of caching, and so on. So I've been trying to figure out how to sort of use some of their API and work it into my own workflow, not necessarily using like the main thing that they're producing, but using their API instead. But I'm also super curious about like what else is out there. So that's kind of the summary of it.
Question over there.
So yeah, I think this is super cool, and reproducibility is really important. I feel like sometimes there's a danger in abstracting all of this stuff away from the user, and it encourages us to continue to use the same methods of looking at our data. So I guess I'm asking, how is the documentation right now? Does the documentation make it really clear for users who want to create their own? And how can you move towards a place of really encouraging people to do it themselves?
Yeah, the answer is very much work in progress. I have some documentation that tells people how to set up a config file and what things you need to put in your notebook in order to make it work with this workflow, mostly just adding a cell that has the tag parameters, which is a Papermill thing. But that's definitely a goal, and I want to make it as easy as possible for people to take that and make their own things with minimal pain. So yeah, work in progress, very much something that I'm thinking about.
Great.
I was thinking when you were talking, I think I've seen the diagnostic plots that get like dumped out for different simulations.
Yeah.
I assume this was replacing those. Is
Yeah.
that the case? 'Cause
Yeah, like so this is infrastructure to like run things that make those. So we want it to be compatible with, say, like the Python scripts that are generating some of those plots. But if people are able to make those into notebooks in the future or change what those look like, then we want to be able to support that too, basically. So.
This just looks a lot better than what I've seen with the, like existing, because there's like already an expectation of all these diagnostic plots getting produced for simulations, right?
Yeah.
And then the notebooks would, so there's already that like automatic nature happening, but then having this is like way better.
Yeah, I assume you're talking about like this sort of thing, like this website screenshot that I have there, just a whole bunch of plots, lots of things, not much text. Yeah. All right, any other questions? Oh, yeah.
Hold on.
Oh, wait a second.
I have a quick question. So my question is mostly like if we want to implement this in a way that when you make some changes to your notebook, these like all these notebooks like run again. And I was wondering like how would the authorizations, for example, from like user perspective will look like? For example, like right now, I think you need to do like, for example, some sort of authorization to get to your like Jupyter Hub. So I was wondering if it would be implementable, like such workflows would be implementable. Basically like changing something in your notebook and then like outside of your Jupyter Hub and then like asking them all to be built, which might be a difficult task to do because of just the authorization, like just logging in and accessing the Dask workers, everything.
I guess I'm a little confused on what you mean by authorizations there. Like, is this like changing what's actually in the diagnostic notebooks or doing this like for one of your own runs? Could you elaborate a little bit more?
Yeah, sure. So for example, like with GitHub workflows, for example, like what I have in mind is something like GitHub workflows. So what you can do is basically like make some changes and then ask like GitHub workflow will go through all the steps and build a Jupyter book for you. But here I was wondering if like, I know that like you're looking at like the workflow in another like way, basically like when the data is updated, all these notebooks are being run through. But I was wondering how like basically just like logging into the Jupyter Hub, if you want to do it without logging into Jupyter Hub, would that be possible to do? Like running it from like using some sort of like a secret key or something. I don't know like what would it look like. I don't know about like like the back end, like what would it look like.
Like automating running it rather than sort of doing it manually.
Exactly.
That's actually not something that I've thought about, but that's a really interesting question. It sort of ties into like making it work on infrastructure outside of just NCAR's computing stuff. So it's definitely something I want to enable in the future. I don't know how automated that will be, but I definitely want to at least be able to have people run this themselves without depending on like an NCAR style Dask cluster, which should be pretty easy to do. It's kind of the next thing on the list. So.
Exactly.
Yeah.
Like, I think you need to like have like some sort of like infrastructure for running them, like making it work on some sort of other infrastructure, and then it would be automatically built like if there are some changes to the notebooks. But that would be like, this is great. This is fantastic. This is really, really great. Great job. Yeah.
Thanks for the input.
Any other questions? I have one more. So I know you mentioned that like this has mainly been ocean so far.
Yeah.
Have you like, is this in like a stable enough point that you can like circulate it around like other sections or like other groups and stuff like that to try to test out and try writing diagnostics?
Yeah, so we've been talking to people in at least the Atmosphere group because they have their own like Atmosphere diagnostic framework and their own ways that they're running things, also mostly based on Python scripts and pushing this stuff to a website. That was kind of the main motivator for trying to get these things to work on Python scripts as well as notebooks, because that'll make some of the migration pain a little bit less hard for them. But yeah, I'm trying to take into account all of the different messy ways in which other people are doing it and communicate with folks in order to make something that will ideally get adopted outside of the ocean section as well. Yeah.
Great.
All right.
Thanks so much.
Thank you.